Okay. Okay, so I want to give you guys the concept of the word, the definition of the word gradient and a concept to go with that. I'm going to also give you a funny symbol. This thing, which is called, I think, a nambla.
Yes.
This is like the del. This is a symbol, not a letter. Doesn't have any meaning in it. It's not a component of a language. It's just a chunk of information. So
It is a thought.
I'm going to give you a definition for this thing too. And the way I'm going to define this funny symbol is I'm going to define it as the partial with respect to x times the I vector plus the partial with respect to y times the j vector. You guys all good with this? Okay, so what category of output is this thing? Good, it's a vector, right? It's got some i's and some j's in it. They're added together, so this thing's a vector. What are these guys doing? Yeah, those are partial derivatives, right? What kind of thing do those need to eat? No, even worse, they don't eat x's and y's here yet because I haven't.
X's or Y's.
No.
They eat functions.
I haven't applied them to a function yet, right? So this is just like the idea of differentiating with respect to x. But I haven't done it to anything. So I think I'm going to need to feed this thing a function before it's going to make me a vector. You guys see that? So I'm going to take this nambla thing, and I'm going to feed to it f of x and y. Cool? And really, this is like a function of a function, right? So the way we're going to feed f of x and y to this thing is we're going to do the partial with respect to xi plus the partial with respect to yj. And then that's like a vector-ish. And I'm multiplying it by f of x and y.
Dotting it?
Yeah, so am I dotting it or what? What is this?
That would be
That is a scalar multiply, right? Because f is itself, yeah, f is some kind of a function, right? But the output of f is going to be a number, like a scalar. Okay, so you're going to get the partial of f with respect to x times the I vector plus the partial of f with respect to y times the j vector, which you could think of as partial f with respect to x, comma, partial f with respect to y. Don't need arrows. Oh, you mean these things?
No.
Ah, so this whole thing is a vector, right? This is the x and the y component of a vector.
Oh,
Yeah, so I don't need a hat over the whole thing. No.
It's a parentheses.
Yeah, this is that stupid parentheses versus Langles. I should really be using the little pointy brackets to denote that this whole object is a vector. Yeah, this is a Langle and that's a Wrangle. The left angle and right angle, Langle, Wrangle. They have names. Don't give me this. All these symbols have names.
It's like regular.
That's not serious. Is that real?
So all of these symbols have names because mathematicians have to type them and talk to each other over the phone about them. Hence the dumb names for stupid stuff like the nambla and the dells, because those are how I type them.
What is del?
Like if I want to typeset them, this thing's a del.
Oh.
I type del and the computer makes it into that. Cool? All right, so this is the gradient. This is what you need to know about gradients right now, is the little nabla makes this happen. Get some practice with them, and then we'll talk about why they're a good idea.